Hello everyone, welcome back to our channel. In this video, we'll be solving some questions related to number systems, okay? So we have altogether 4 questions here. We'll be solving each of these questions individually. So let's start with our first question. So we have our first question here. Our question is 0 a rational number? And can you write it in the form of p divided by q, where p and q are integers and q is not equal to 0. Now, the answer to this question is yes, 0 is a rational number. Now, can we write this 0 in the form of p divided by q? Of course we can, right? So we can write this 0 as 0 divided by 1. We know that 0 divided by 1 is 0. Or we could also write this as 0 divided by 2 or 0 divided by 3. All these numbers give us 0, right? So we can write 0 as 0 divided by 1 or 0 divided by 2 or 0 by 3. And we know that 0 and this 3, both of them are integers, right? So the answer to our question is 0 a rational number? Yes. And can we write this in the form of p divided by q, where p and q are integers? Yes, we can do that as well. Now, you might ask, why is our answer yes, right? Why is 0 a rational number? Now, the answer to that question is actually in our question. What I mean by that is, if a number can be written in the form of p divided by q, where p and q are integers and q is not equal to 0, then that number is a rational number. And we just proved that we can write 0 in the form of p divided by q, where p and q are integers, and hence 0 is a rational number, okay? So the reason this question is interesting is because we get the answer to why this 0 is a rational number from our second question, okay? So again, if we can write any number in the form of p divided by q or in fractions, then that number is a rational number, and we just proved from our second answer that we can write 0 in the form of fractions, right? And hence 0 is a rational number, and our answer is yes, okay? So that's our answer to our first question. Now, let's look at our second question. So we have our second question over here. We need to find 6 rational numbers between 3 and 4, right? Now, this question is also interesting because we can find rational numbers between 3 and 4 in so many ways, okay? But in this video, we'll just look at 2 different ways. So our first way is the most easiest way, okay? So let's write our 3 over here, and let's write our 4 over here, okay? So we are going to find 6 rational numbers between 3 and 4. So we know that 3.1 lies between 3 and 4, right? 3.2 also lies between 3 and 4. 3.3 lies between 3 and 4. 3.4, 3.5, and finally 3.6 also lies between 3 and 4. And these numbers, which lie between 3 and 4, are actually rational numbers, because a decimal number that terminates is a rational number, okay? So if you are not satisfied with that definition, we can also write these numbers in the form of fractions. And we just discussed in our question number 1 that if you can write these numbers in the form of fractions, then they are rational numbers, right? Any number which can be written in the form of fraction is a rational number. So we can write this 3.1 as 31 divided by 10, okay? So 31 divided by 10 is 3.1. Similarly, 32 divided by 10 is 3.2, and then 33 divided by 10 is 3.3. So if you go on like this, we can write these decimal terms in the form of fractions, okay? So we have 35 divided by 10 and 36 divided by 10. So these numbers can also be written in the form of fractions, right? So they're obviously rational numbers. And we also know that they lie between our first number 3 and our last number 4. And so we have just found 6 rational numbers between 3 and 4, right? So we have 1, 2, 3, 4, 5, 6, and done. So we have solved our second question. Now, a second way to deal with this question is, so we convert this number 3 and this number 4 in the form of fractions first, okay? So we can write this 3 as 3 divided by 1, right? And we can write this 4 as well in the form of 4 divided by 1, okay? Now, depending on the question, right? So in this particular question, we need to find 6 rational numbers. What we do is, if we need to find 6 rational numbers, we add 1 with that 6, okay? So we have 6 plus 1 is 7, right? So we have 7 over here. What we do is, we multiply both this numerator and the denominator with this number 7, okay? So if we do that, we're going to get 7, okay? So here also 7. And we're going to get 3 times 7 is 21, divided by 1 times 7 is 7. Now, these are actually equivalent fractions of this 3 divided by 1, okay? So 21 divided by 7 is also 3, okay? It's not a different number. 21 divided by 7 is 3, right? Similarly, we are going to do the same thing over here. So we multiply both the numerator and the denominator with 7. And we are going to get 4 times 7 is 28, divided by 1 times 7 is 7. So this particular number is 3, okay? So 21 divided by 7 is 3. This particular number is 4, right? 28 divided by 7 is 4. So we can write 3 like this, 21 divided by 7, and 4 like this, okay? 28 divided by 7. They are both the same thing. Now, why do we need to write these numbers 3 and 4 like that, right? Because it makes it easy to find the rational numbers between this 3 and 4, okay? So we can write the 3 as 21 divided by 7, right? And we can write the 4 as 28 divided by 7. Now, what we can do is, we can increase the numerator serially, okay? So we have 21 divided by 7. Our next number is 22 divided by 7, comma, our next number will be 23 divided by 7. And so if you go on like this, we're going to get 24 divided by 7, 25 divided by 7, 26 divided by 7, and then finally we have 27 divided by 7, okay? So these numbers lie between 21 divided by 7 and 28 divided by 7, which is our 3 and 4, right? And they are obviously rational numbers because they are fractions, right? And in this way, we can again find the rational numbers between any two numbers, okay? You just multiply the numerator and the denominator with the number which is greater than 6, right? Because we needed to find 6 rational numbers in this case. And then you find the middle terms by increasing this numerator serially, okay? So in this way, we can find rational numbers between any two numbers in two different ways, okay? Now, let's look at our third question. So we have our third question over here. We need to find 5 rational numbers between 3 by 5 and 4 by 5, right? So again, we can find the rational numbers in two different ways, okay? So first, let's try our first method. So we have our 3 divided by 5, right? Now, 3 divided by 5 is 0.6, okay? So 0.6. And then we have 4 divided by 5, right? And 4 divided by 5 is 0.8, okay? Now, what we can do is, we can always add zeros at the end after the decimal point, okay? It does not make any difference, okay? So 0.60 is equal to 0.6. So similarly, we can again add 0 over here as well, okay? So 0.8 and 0.80 is the same thing, because you can put as many zeros as you want after the decimal point at the end. It does not make any difference, okay? So if you have, let's say, 10.0 rupees, then you can write this as 10.00, and you can add another 0 and as many zeros as you want. It's still going to be 10, okay? So similarly, if you have 0.1, you can add as many zeros as you want. It's still going to be 0.1, okay? So similarly, that's what we are doing here, okay? So we had 3 by 5 as 0.6. We can write that as 0.60, and then 4 by 5 as 0.80. Now, after we have written that much, what we can do is, we can find 5 rational numbers between this 0.6 and 0.8, okay? So we have 0.8 is 0.80 and 0.6 is 0.60, right? Now we can just write the numbers after 60, which is going to be 0.61 and 0.62 and 0.63 or 0.64 and then 0.65. Okay, so these numbers lie between 0.6060 and 0.80, right? And these are again rational numbers because they are terminating decimal numbers. Okay, so again we can write them as 61 divided by 100. Okay, in terms of fractions. Okay, for 0.65 it's going to be 65 divided by 100. So obviously they are rational numbers, right? And they lie between 0.6 and 0.8, which is 3 divided by 5 and 4 divided by 5, right? And in that way, we have found the 5 rational numbers between 3 by 5 and 4 by 5, okay? So that's our first method, okay? You need to use a little bit intuition to use the first method. Now, for our second method, it's more mathematical than intuition, okay? So we have 3 divided by 5, and then we have 4 divided by 5, right? Now, we need to find 5 rational numbers. And like I said before, you just add 1 with this number 5, okay? So if you need to find 5 rational numbers, you add 1 with this 5, and you're going to get 6, right? And what you do is you multiply this number 6 in both the numerator and the denominator of our fractions, okay? So we have our 3 by 5. We can multiply both the numerator and the denominator of this 3 by 5 with 6, right? And it's going to give us equivalent fraction of this 3 by 5, which is 18 divided by 30. Similarly, again here as well, we are going to multiply both the numerator and the denominator with 6, and we are going to get 24 divided by 30, right? Now again, this 3 by 5 and this 18 by 30 are same thing, okay? They are equal, okay? So if you cut this with 6, right? 6 times 3 is 18 and 6 times 5 is 30, okay? It's 3 by 5, okay? I'm just writing it in terms of a bigger number because it will be easier for us to find the rational numbers between this 3 by 5 and this 4 by 5, okay? So we have our 3 by 5 as 18 divided by 30, right? In terms of bigger number. And then we have our 4 divided by 5. This was our 4 by 5, okay, as 24 divided by 30, right? Now again, we just increase the numerator serially. So we get 19 divided by 30. And then we can write 20 by 30. And then 21 divided by 30. And then 22 divided by 30. And then 23 divided by 30. So these numbers lie between 18 by 30 and 24 by 30, which is our 3 by 5 and 4 divided by 5, right? And they are all rational numbers because they are fractions, right? And we have, if we counted, 5 rational numbers between 3 by 5 and 4 by 5. And done. That's how we can find the rational numbers between any two particular numbers or fractions, okay? Now, let's move to our final question. So, our final question is true or false, okay? So, it must be pretty easy, okay? But you also need to give reasons for your answers, okay? You just can't write true or false by guessing, okay? You also need to give your reasons. So, let's see. So, we have our first question that every natural number is a whole number, okay? And this statement is true, okay? Now, why? Because natural numbers are the subset of whole numbers, okay? What do I mean by this? So, our natural numbers starts from 1 and then it continues and goes on and on and on, okay? Whereas our whole number starts from 0, okay? And again, it also continues and goes on and on and on, okay? So all the natural numbers are obviously whole numbers because we start our natural number with 1, whereas we start our whole number with 0, right? So obviously the whole numbers have all the natural numbers. Actually, it has one extra number. That's a different thing. But all natural numbers are obviously whole numbers, okay? It's like saying all humans are animals, okay? Obviously, all humans are animals, right? Because humans are a subset of animal. There are other animals as well, but all humans are definitely animals because humans are a subset of animals, okay? So similarly, all natural numbers are whole numbers because the natural numbers are a subset of whole numbers, okay? But all whole numbers are not natural numbers because we have this extra 0 here. Similarly, all animals are not humans, okay? We might have rats, cats, dogs, right? But all humans are definitely animals, okay? So that's our first statement. Now let's move to our second statement, okay? So our second statement is every integer is a whole number. Now this statement is false, okay? Now to understand why this is false, you need to know what is an integer, okay? So obviously we now know what is a natural number, and then we know what is whole number, right? Now, if you include the negative natural numbers, right, which is going to be, dot, 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 -3, -2, -1, comma 0, comma 1, comma 2, comma 3, comma dot, 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 okay? If you include the negative natural numbers in the whole numbers, then you get the set of integers, okay? So this is the set of all integers, okay? Now, is every integer a whole number? No, because we have negative numbers here, and these negative numbers are not whole numbers, and so all integers are not whole numbers because we have negative numbers, okay? Are you getting this? These negative numbers don't lie in this whole number, okay? And our second statement is saying every integer is a whole number, okay? Which is just saying that these negative numbers are all whole numbers, but they are not. So our second statement is false, okay? Now for our third statement, okay? So we have every rational number is a whole number. And this statement is also false, okay? Why? Because a rational number is a fraction, right? A number which can be written in the form of fraction, right? So we can write 1 by 2, which is a fraction, right? And this is a rational number, right? But it does not lie in the whole numbers, okay? So you don't have this 1 by 2 in whole numbers. 1 by 2 is equal to 0.5, and in the whole numbers, you don't have 0.5 or 0.6, those numbers, okay? But they're rational numbers. So we just proved that 1 by 2 is a rational number, but it's not a whole number. But our third statement is saying every rational number is a whole number, so it's definitely false because again we just showed that 1 by 2 is a rational number, but it's not a whole number, okay? So in this way, our first statement is true, every natural number is whole number. Our second statement is false, every integer is not a whole number, negative integers are not whole numbers. And finally, our third statement is also false because all the rational numbers are not whole numbers. And that's it. So if you enjoyed our video, please give us a thumbs up and subscribe to our channel for future maths videos. Thank you.